I am recording. So what I thought we would do today is I want to introduce you to how optimization in linear programming is done in the real world. I mean, we looked at doing it graphically last time, and I suggested that you use Desmos to do the graphing because it's very, very easy to find the corner points of a critical region in Desmos. As opposed to your TI-84. So I'm strongly encouraging you, underline strongly, to use Desmos if you're going to do any kind of linear programming graphically. In this course, okay, and on the exam, we're only going to worry about problems that you can solve graphically. But you have to understand that in the real world, a lot of problems come with more than two decision variables. Okay, remember, decision variables are the unknown things you're trying to find, like X and Y, or X1 and Y1. Now, if I've only got two of them, I can graph them on a two-dimensional surface like a Desmos grid. But if I have three of them, or four of them, or more of them, I can't graph it in 2 dimensions. So the graphical method kind of falls by the wayside. So what I want to show you today is how to do linear programming in Excel. Okay, Excel is something you're probably going to see when you get out there in your careers. It'll probably still be there. I'm going to show you desktop Excel, like Microsoft Office Excel, since a number of you said that you have that. But I'm also going to show you how to do this in Office 365. Since I know for sure all of you have access to that, and I'll show you how to log in to it. Okay, so the notes that I have for today have a lot of explanation on how to set up the solver, which is what this program is called in Excel. It's an Excel add-in. And in Office 365, it's a third-party piece of software. Okay, so the solver is that's going to help you do optimization problems that are more complicated that you can handle graphically. Although, like I said, if you like the graphical method, that should be good enough for the exams here. But again, it's worth it to you to get comfortable with Excel. I'll also show you in Office, Microsoft Office Excel, the analysis tool pack, which is something you're probably going to use in your next math class, GBS 221, which is a stats class. Again, it's important to understand that a lot of math curriculum, like the stuff we're doing in math class, shows you how to do this by hand so you understand what's underneath. But when you get out there and you actually are doing it for a living, you're going to need to do software. So having the I know how to do this by hand helps you check whether or not the software solution is reasonable. Okay, so that's pretty much what it is. Not that you're worried the computer is going to make a mistake, but usually there might be a mistake in the setup or in the interpretation of your technological solution. Okay, so just want to make sure everybody understands what we're doing. So this is kind of a necessary, real world excursion we have to take for optimization. I'm going to start by sharing my browser with you to show you where everything is in the course that we're up to right now. Okay, so we're currently in week 5. Okay, we didn't have any class on Monday because it was President's Day. So there's really only one week 5 set of notes, this linear programming with Excel notes. And like I said, they're extremely wordy. I am not going to read them to you. Okay, and we're not going to go through all of the notes, they're there for you as reference. What I plan to show you is a couple of examples, okay, using Excel. All right, here's a video. If you would like a video on how to get the Solver app in Office 365 Excel, I've put that up here. The other thing I want to make sure you're aware of is our first exam is coming up this week. Okay, what I've uploaded here is an exam, a practice exam, my version of a practice exam with my solutions written out. Okay, And then if you take a look down here, you'll see you have homework for linear programming with Excel. And for the homework, you're going to need to use Excel. Okay. There's a practice exam for you to try, and that's on the material that's in the section, the Unit 1 stuff that we've done since the beginning of the semester. Okay, so this is on the first 5 weeks of the course. All right, so it's solving linear equations, the matrix operations. It's on, linear programming and stuff like that. But again, my point is use technology. Okay, this exam does not require any kind of a lockdown browser because I expect you to use all these tools up here. See them? Okay, linear programming tool, Desmos calculator, Symbolab matrix, Desmos. In the real world, you need to be able to leverage these computational tools to answer questions. Okay, now there are some applied problems, which you'll see when you do this practice exam. The practice exam says it's 20 points, but I'll give everybody 20 points for it, regardless of how you do on it. So this is just an attempt for you to see what the exam looks like before you actually take the real one. Okay, so the practice exam you can take a couple of times. Please look at my solutions first, so you have some idea as to what types of questions will be on it. Okay, this is the real thing. Okay, and it's timed. Okay, so this you'll only be able to open once. Okay, if you can at all show work for any of your problems, write it down on paper, and then after you finish and submit the exam, upload your work to this assignment. This assignment will let you upload multiple files, or if you want to take a bunch of photos and use an app to make a PDF out of them, you can do that. If you have a scanner, you can use that, but upload your work. That way I can give you partial credit on the exam. Okay, I hate automatically graded stuff, and I'm sure you do too, because it's either right or it's wrong. And it doesn't matter what kind of mistake you made in setting up the problem or doing the problem. So having you show me your work, okay, will allow me to go back and regrade this exam. Okay, so please don't freak out if you get a lower score on this exam than you think you should have gotten, because I will go back with your work and regrade these. Okay, and again, when I regrade them, the score goes up because I'm giving you partial credit. Okay, so what I specifically, again, you're not getting, it says 20 points, but let's say you try it a couple of times and you're getting like a 15 on it or whatever. I will give you the whole 20 points. Okay, so I will give everyone 20 points for the practice exam. Okay, I will give everybody the 20 points. So in that regard, it won't affect your grade because everybody gets the same score on it. This one, of course, is up to you how well you do on it. And like I said, please upload your work so I can give you partial credit. Okay, so you have my practice exam with solutions. Let me just bring that up and show you. Okay. Takes a minute to load. Again, I'm showing you how to do these, okay? And I'm showing you my answers, okay? And I'm giving you tips. So again, take a look at my practice exam before you try your practice exam, okay? And again, you're allowed to use any of the technology that we've talked about. If you like Excel and you want to use Excel, feel free. Okay, I want you to be comfortable with technology. Your majority of you are business students, and essentially you need to be comfortable with it. Okay, so as far as Excel is concerned, I believe all the linear optimization can be done graphically on the exam. Okay, all the linear optimization can be done graphically. You will need Excel for homework 1.9. Okay, so again, I want you to get comfortable with it, but I'm trying not to make it a requirement. Okay, believe it or not, in this course prior to right now, okay, they had linear programming problems that you had to solve by hand with a different manual method called simplex, which was even more tedious than using Excel. Personally, I think using Excel is going to be very simple. Okay, so they did have problems in this course that you couldn't do graphically, but required a much more long and drawn out hand by hand method that, again, is interesting for historical reasons, but it's 75 years old. We don't need to do it by hand anymore. We have spreadsheets. Okay, so okay. Right, so no, the question is, do we need Excel for the exam? And the answer is no. You should only have problems with 2 decision variables. Okay, and again, if I go back up here to my practice exam with solutions, I will attempt to scroll down so you can see it, because again, I know everybody's kind of nervous about all this. Okay, so there's matrix stuff. There's solving equations, whatever method you care. See X and Y. Okay, this one, okay, this one problem, I believe, might require Excel because there are 4 decision variables. Okay, so maybe the one problem on the exam. Okay, so again, what determines whether or not you need Excel is how many decision variables there are. Okay, so here's one that you can do graphically. Here's another one you can do graphically. Okay, and I'm showing you the graphs. Okay, so to answer your question, no, except for one problem. Okay, except for one problem. So again, please try to get the Excel version down. And again, if you're having trouble with Excel, okay, I want you to reach out to me and say, hey, I only have Office 365. Can you show me again how to do this? All right. I'm assuming everybody's going to try homework 1.9 and try to work out the whole Excel thing. All right. And like I said, my notes are going to give you the information you need to get started. Okay. So again, please don't think, well, you know, we're not doing a whole bunch of examples like this. You're not walking me through how to set it up. In the real world, you're going to need to follow documentation to set up what you need to solve a problem. I'm here if you need to reach out for help. I'm willing to do a one-on-one with you, whatever you need, but please try the Excel approach. This is going to help you not only going forward in your career, but in GBS 221. Okay, since that's going to be much more heavily Excel based than this course. Okay, so let me stop and ask again, any more questions about the exam? Any more questions about the exam and how we're going to do it? Again, look at my practice exam, then you try your practice exam a couple of times, and then finally, when you're ready, take the real one, show me your work. Okay, any other questions about it? Okay, everybody good with this? Again, as always, the exam and your homework is due at 11:59 p.m. on Sunday. Again, do yourself a favor. Please don't wait until like 10 o'clock to start the exam. Okay, actually, you know, give yourself a little bit more breathing room, get everything together. Like I said, anything you can use that we've done in the course or any of the tools that I have are more than welcome. Okay, it's going to be similar to the practice exam. I believe there's about 20 questions. Again, take a look at the practice that I did and take a look at your practice exam. The real exam will be very similar. Okay? So very much like practice. Okay? All right. And again, I want to again scroll down in case you haven't bothered to look ahead. All right. Go all the way down to the bottom of the course almost after the final. I want to make sure you see that I have online tools and calculators grouped by topic. Okay. This is a separate module because again, I realize it's useful to have them where, where you're actually doing the homework. So in that particular week's module, but then I have them separated in case you're like me and you want to look for them by topic. Like I don't remember what week it was in. Okay, just show me where the tools are for matrices. Okay, so here they are in their own module, online tools and calculators, and they're organized by topic. Okay, so here are all the Unit 1 tools, the general tools, and there are more tools going forward. Okay, so please take a moment, if you haven't done so already, and get familiar with the layout of the course so you can find what you need. Okay, I believe down here I have, okay, I don't have a link to Office 365 per se because it's so easy to find. Okay. Let me just show you how to do that. So I'm just opening up another browser tab like this. Okay, I'm searching for Office 365. Okay, go down past the ads and click on www.office.com. Okay, and again, okay, it says sign in. Okay, so search for Office 365 and sign in with your Maricopa email. Okay. So again, since this is provided to you through the college, you need to use your Maricopa credentials to get in there. So I'm going to say sign in. Since I've signed in before, it's going to ask me sign in with this. This is my Maricopa credential. Okay, if you're signing in for the first time, it'll actually have, your login, whatever. And you type in your Maricopa credential. Okay, and then it will probably give you another box that says sign in with your Maricopa credentials, right? Giving you, taking you to your enterprise sign in. Okay, so again, because I've used this multiple times, this is already set up for me. So it's getting me into Office 365 right away. Okay, let me bring up my notes so you can see how to do that. Okay, so give me a moment and I'll get my notes up. Okay, and let me share those with you. All right, so now you should see my notes. Section 1.9, using Excel for optimization problems. And again, in case you're wondering, okay, this is necessary if there are more than 2 decision variables. Okay, remember, decision variables are the unknowns you're looking for. Okay, and most of the problems, all of the problems we talked about last time require just 2, X and Y, all right? So if you have more than 2 unknowns, right, you're going to need Excel in order to do it. It won't be possible to solve it graphically, all right? Now, again, before I get started, let me just ask, okay, so type yes in the chat if you're comfortable with Excel. Okay, type yes in the chat if you're comfortable with Excel. That means you're comfortable entering formulas, you're comfortable navigating, you know what you're doing roughly. I'm not saying you're an expert. Just please give me a yes if you're comfortable with Excel. I want to get a rough idea of how much detail should I go into. Okay, so that looks like the majority of you, but there's a few of you not so comfortable. Okay, here's a basic review. Okay, as you know, those of you who are comfortable, each cell has an address that's referenced with a column letter. So A, B, C, D, all the way out. And then you get double A, double B, you know, that sort of thing. A, B. And then rows. Okay. And the rows are numbered. Okay. So that means each cell has coordinates. Like A1 is the top cell in the leftmost corner. Okay. If you want to add values or do any kind of a arithmetic operation on quantities in a cell, you need to start a formula with an equal sign. That tells Excel that you want to compute something using cell values. So again, you can see examples here. Equals A1 plus A2 is going to add those two values. Okay, you must tell Excel when you're multiplying. In other words, you have to use the star as your multiply symbol. Excel doesn't handle implied multiplication. You have to specifically tell it multiply. Okay, so you have to say equals A1 times A2 if you want to multiply those. There are also lots of built-in functions in Excel. Like you can highlight the elements in a column, okay, and then you can say equals average, take that range of elements, okay, and Excel will average out the elements in your column, okay. Excel does know about order of operations, so you can put parentheses in your formulas when you need them, okay. If we're going to be doing optimization, we're going to need to use formulas, okay, so you need to get comfortable with this, okay. Now, again, in case you're getting concerned and you're saying, wait, she said there's one problem on that exam I need to use Excel for. Suppose I can't get this down. Just show me as much work as possible, right? So you can show me, here are my decision variables. Here's the objective I'm trying to maximize. Here are my constraints. Those are the three parts to an optimization problem. Decision variables, function that you're trying to optimize your objective, and the constraints, okay? I will be very generous with partial credit, okay? But just show me that you're thinking about it the right way, even if you weren't able to basically get it to work the way you want, okay? So again, I want you to get comfortable with it and not obsess so much about getting graded on it, okay? I don't know how else to get people to try it other than to put a problem on the exam. Otherwise, people say, oops, I won't bother. It's important, okay, that you learn how to use Excel, all right? So that's kind of a little primer about how formulas work in Excel, and we'll show you some examples, don't worry. All right, so we have an Excel solver, okay? And like I said, on regular Office Excel, Microsoft Office Excel on your desktop, it's what's called an add-in. It's not extra, although if you have older versions of Excel, you may need an installation CD, not for like Office 2010, okay? So what I have here, and I'm not going to read through all this, okay? I'm showing you how to get a hold of the solver in various instances of Excel. Since I don't know what you're using, I need to go through everything here. So here's Office 365. Okay, and again, you can basically get Office add-ins from a drop-down menu there. It won't work for me to show you because you're probably saying, why don't you just show us? I've already got it installed. And for some reason, once you install it, you're stuck with it. Okay, so I can't like back it out, get rid of it, and then reinstall it and show you. Okay, I can show you how to use it, but I can't show you the install process. All right. So please go into these notes, okay, and actually try this yourself. If you're using Office 365, okay, or here's Office 10, okay. Here's older versions of Office. Okay, so there are a bunch of different ways to actually get it working. Okay, so again, I showed you Office 365. Let me just go back out there again. All right, so I can open a spreadsheet I already have that has some linear programming examples in it. Okay, if you're opening a brand new spreadsheet, you'll see, let me go back over here and show you. I'll close that one. See these over here? These are all the components for Office 365. You've got Word, you've got Excel, PowerPoint, okay, OneNote, everything that Microsoft offers as part of their cloud-based product, okay? So if you can get here and you can log in with your Maricopa credentials, you've got Excel, right? So the first time, you would probably click on a new Excel file, okay? And that would open up a brand new spreadsheet. I've already got one that I've been using, so I'm just clicking an existing spreadsheet, okay? And again, if I want to show you this, I'm going to have to temporarily move the chat so you can kind of see things. You see this box right here? This is the solver dialog box, okay? And once you enable the third-party add-in, according to the directions in my notes, this will come up, okay? And again, it's pretty straightforward. You can pick the cell to optimize. You can pick the cells you want to change. You can tell it what your constraints are, okay? So again, we can look at examples in a minute just so you can see how they work, okay? Now, again, I have a lot of stuff going on over here. So I'm going to minimize my self view, and I may from time to time either need to move the chat around or close it. So if you have questions, it's going to be important to unmute yourself and ask, because there's a lot going on the screen here, okay? So let me start by going back to the notes I had, and let me show you a sample problem statement, okay? A company manufactures two types of products, cogs and sprockets. Cogs sell for $1.20 each, and sprockets sell for $80 each. Okay. The company policy requires that they make at least 1,000 total units. Okay. At least means that number or more. Okay. So they have to make 1,000 cogs and sprockets a month. Cogs require 5 hours of labor per unit, and sprockets require 3 hours of labor per unit. The total cost of labor is $12 an hour, and a total of 8,000 hours are available per month. Okay, determine a monthly production schedule that will maximize company profit. Okay, remember I said, when you start these optimization problems, begin at the end. Look at the last line that's here. Okay, so determine a monthly production schedule that maximizes the profit. Okay, so if I'm looking at that, the first thing I need to know is, what are my decision variables? What am I trying to find out? Well, a monthly production schedule means how many of each of your products do you need to make, right? That's what a production schedule is. How many of each product, okay? Now, if you take a look at the rest of the word problem, you can see we've got two products. Okay, so my decision variables, I'm going to say let X be the number of cogs, and let Y be the number of sprockets. Okay, and there's space on the next page for me to write all this out, but I want to kind of keep the word problem up here for a while so you can see how I decode it. All right, so focus on the last line and start with decision variables. The next thing you want to figure out is, what's your objective? What are you trying to have happen? Well, you can see right over here, we want to maximize profit. Okay, so maximizing profit is the objective. Okay, so we want to figure out how many cogs and how many sprockets the company needs to make every month to maximize profit. And again, you can see over here, I have a certain amount of, okay, what's this? If I'm selling them for a certain price, okay, then this is revenue, right? The amount you're charging your customer is called revenue, okay? And you can see that we have a certain amount of cost, okay, here. Okay, we have costs. All right, so what you want to realize from looking at the problem, and with these word problems, you need to read multiple times, okay? You might remember from either accounting or from one of your business classes that profit equals revenue minus cost. Okay, so you have kind of at this point a strategy for getting started with the problem. You know what your decision variables are. Okay, their number of cogs and number of sprockets we're going to make monthly. You know what your objective is. It's maximizing profit. And it looks like you're going to have to build the objective function from your revenue and your costs. Okay, anything else that's left, okay, for example, this part over here, cogs require 5 hours of labor per unit and sprockets require 3 hours of labor per unit. And I have a total of 8,000 hours. That looks like a constraint. In other words, I can't make as many cogs and sprockets as I want, okay, because I'm constrained by how much labor. Here's another constraint, that I have to make at least 1,000 units. That means if it turns out that my maximum profit happens when I only make 850, that's no good because I need to make at least 1,000. Okay, so the stuff that's highlighted in pink are going to be the constraints. Okay, so remember the parts to an optimization problem. There's decision variable, then objective function, and then constraints. So if you start at the bottom of it, you'll get your decision variables right away, okay? And you'll get a hint as to what your objective is. And then you have to go back through the word problem and figure out how to build the objective. What's left after you do that are the constraints. So we're going to go through this step by step, okay? Because again, it's the setup that's important. And once we have Excel, it's going to be easy to actually solve. Okay? So let me ask at this point, questions about how to get the information from an optimization problem. Anybody have questions on how to get the information from an optimization problem? I know everybody says, I'm not good at word problems. You're going to get good at word problems because you're going to practice them. All right, so start at the bottom and start in order. Okay, so we're doing it in the order: decision variables, then objective, and the last bit is constraints. Okay, so we're going to do them in that order. All right, so I'm going to move from the problem statement over here to the setup. Okay, so this walks you through the process. Okay, so I'm going to let X1 be. Now, you can call them X and Y, but it's more conventional in these types of problems to put subscripts on X. Okay, so for example, X sub 1 is the first variable, X sub 2 is the second variable. Okay, you could call them, Tom and Harry, it doesn't matter. Okay, as long as you know what they represent. So I'm going to let X1 be the number of cogs to manufacture monthly. Because again, the problem is talking about monthly manufacturing. All right, and I'm going to let X2 be the number of sprockets to manufacture monthly. Okay. All right, so my objective here is maximizing profit. And again, you have to describe in words how you calculate profit. Why in words? Well, because the problem came at you in words. Okay. And if you can describe to somebody else how you're going to go about solving the problem, then you really understand it. If you ever find yourself in the situation where you're thinking, I couldn't really explain this to a colleague, okay, you really don't understand the process. Okay, I believe it was Einstein who once said, the mark of truly understanding something is that you could explain it to your grandmother. Okay, so again, don't resist the idea of explaining with words. Okay, it's not all about calculating. Okay, we're going to leverage that onto the spreadsheet. Okay, what's important is to understand the problem. So what we want here is profit equals revenue minus cost. Okay, so I'm going to call profit P. Okay, and they told me my revenue was how much I get from selling each one of these things. Okay, now if you look down over here, I can sell a cog for $120 and I can sell a sprocket for 80. Okay, so that's the per unit price. Okay, now again, if you want to know the total amount of revenue for selling for cogs, you're going to multiply 120, which is the per unit price, by the total number of cogs, and that's going to be X sub 1. Okay, the total amount of revenue for selling sprockets is $80 per sprocket times X sub 2, which is the total number of sprockets. Okay, so I want to make sure I have my revenue over here. So that's 120 times X1, which is cogs, plus 80 times X2. All right, so there's my revenue. Put an arrow to it so you can see where that's coming from. And now I have to subtract my cost. Cost is a little harder to figure out. Let's look at the problem again. Labor costs $12 an hour. Let's assume everybody working in this factory makes $12 an hour, which is not reasonable, but it simplifies the problem. Okay. COGS require 5 hours of labor per unit. We're only considering labor costs here. We're not considering material costs or anything like that. Again, to simplify the problem. In the real world, the problem would be a lot more complicated. So we're just talking about costs to make the cog, okay? Well, if labor costs $12 an hour and I need 5 hours of labor for each cog, okay, then I need 5 times $12 to make a cog. Okay, does that make sense? Okay, does multiplying the per hour cost Okay, does this make sense? Multiplying the per hour labor cost by the number of hours needed. Does that make sense? Okay, because you want a cost in dollars, right? Okay, this is in dollars per hour, and this is in hours. If you multiply them together, hours cancels out, and you're left with dollars. Okay, that's why reading this is so important. Likewise, okay, sprockets require 3 hours of labor per sprocket, and the cost is $12 per hour. So I need to multiply 12 times 3 to get the cost to make a sprocket. Okay, again, please do me a favor and give me some feedback. Are you okay so far? Give me some feedback, yes or no? Just type in the chat, yes or no. Okay, if you're not typing yes, then I expect a question.
Yes, I'm good.
Okay, ask a question if you're lost. Please, this is important because this is the part that we can't do with Excel. We need your brain to handle this part. Okay. Again, I'm only seeing a couple of yeses, so I'm kind of worried at this point. Okay. I know there's more than just 4 or 5 of you on. Okay. Let me go back here and show you what I'm talking about. Okay. So these are in dollars. This is $120 per unit. Okay. So if you look at the units here, this is $120 per unit, and that's times units. Okay, the units cancel out and you're left with dollars. Same idea over here. Okay, I have 5 hours to make one times $12 per hour. Okay, and this is going to be times X1, and that's in units. Okay, so look at my units over here. Okay, for cost. Okay. The 5 hours per unit is how long it takes to make a cog. The $12 per hour is how much my labor costs, and X1 is in units, okay, of cogs. Now look what happens with the units on my stuff, okay? Hours cancel out, units cancel out, and this will leave me with dollars, okay? Paying attention to the units in a problem will sometimes help you solve a problem. In other words, looking at this led me to believe, well, I can't just multiply X1 by 12 because that would have wrong units. That would give me dollars times units per hour, which doesn't make sense. I need the hours and the units to cancel out. So that's where the 5 is coming in. Okay. And likewise over here, I've got 3 hours per unit times $12 per hour for the labor times X2 units for the sprockets. Okay, and units cancels, hours cancels, and I'm left with dollars. Okay, again, cost needs to be in dollars. Okay, so it's important that the units work out. All right, so again, I kind of scribbled a whole bunch over here. I don't want to make it hard to understand. But here's what I've got now, 120x1 plus 80x2. This minus sign is going to distribute to everything that's passed. Okay. That's why that second bit is in parentheses. Okay, if I look at 5 times 12 times x1, that's 60x1. Okay, and then the minus also distributes to the second term, the minus outside. And I have 3 times 12 times x2. Okay, that's 36x2. Okay, and hopefully you can tell I've got some like terms here and some like terms here that I can combine. And I get a profit equation when I do that of 60x1 plus 44x. Okay, so let me stop and ask at this point, is everybody okay with the objective function for profit? Everybody okay with the objective function for profit? Can you tell where it came from? And yes, at this point, we're assuming you can handle profit is revenue minus cost, and that you can handle this much algebra. Okay. All right, we're good. Okay. Good. It says, now what constraints affect your ability to manufacture cogs and sprockets? And they say it might be helpful to reread the problem again. Well, we highlighted them in pink the first time, okay, which is a good strategy. It's a critical reading strategy to highlight the stuff that's important in different colors, okay, so you don't have to go back and do a lot of rereading. So I need to make at least 100 units. So I have a production policy, a company policy, that it says the minimum production that I'm required to make. And also I have a limitation on my labor hours. Okay, so I have 2 constraints in the problem. I'm going to come back here and I'm going to say, okay, production policy. And labor, available labor. Okay, so those are my constraints. And they want us to translate them into mathematical inequalities. Okay, so let's take a look. Company policy requires that at least 1,000 units total. Total means cogs and sprockets. So you're thinking total of cogs and sprockets. Oh, that's x1 plus x2. And at least means 1,000 is the smallest you can make. So that means the total of cogs and sprockets has to be greater than or equal to. So here's the first inequality. Okay. And the next one is the labor hours. Well, we can see up here, a cog requires 5 hours to make, and a sprocket let's see, cogs is first. X1 is cogs. So 5 hours to make a cog and 3 hours to make a sprocket. Okay, so the total number of labor hours for making a cog is 3x1, 5x1 rather. Okay, that's the total number of cog hours, labor hours. And the total number of sprocket labor hours is 3x2, right? Because these variables are going to contain the total number of cogs and sprockets that I have to make, all right? So this expression, 5x1 plus 3x2, is my total labor hours to make everything, okay? Cogs and sprockets. Now I've only got 8,000 hours, which means the maximum I can use is 8,000. So this has to be a less than or equal. Okay, so there are my two constraints. Also, cogs and sprockets have to be positive numbers, right? There's no point in talking about -5 sprockets. Okay, so let's have some non-negative constraints. Okay. All right. So again, the rest of this actually walks you through using Excel 2010. Okay. So it actually walks you through it. Okay. Which again, what I'm going to do is show you both ways. Okay. Show you the Excel solver in the desktop version of Excel and also show you Excel 365. Okay. Do you have a preference for which one you want to see first? Okay, which one do you want to see first? Can you give me some feedback, folks? Okay, 365. Again, I'd like to show you 365 first because I know everybody has that. Okay, so let's go back to Office 365. Okay, and again, remember this solver dialog box here, my notes show you how to get this. Okay, if I show you how to do that, okay, pretty much you're not going to be able to see it because I've already used it. Okay, so please follow the directions here. Okay. Now let me show you the way I set up my spreadsheet. Okay, typically I have a column that will have notes in it. Okay, so basically label what is on the spreadsheet. Okay, label what is on the spreadsheet. So I'm using column A here for text. All right, so I have the number of cogs manufactured per month, which is variable X1. That's going to be in cell B2. Okay, and again, you can have these cleared out. They don't need to be zeros. Okay, so they could just be empty. Okay, number of sprockets manufactured per month X2, that is going to be in cell B3. Okay, so does everybody understand? Column A has labels, column B will have data. Okay, so I'm just pointing to what's here. All right, this is important. If you don't put anything on the spreadsheet other than your data, you will get lost. Okay, so make a point of labeling these things. Okay, the next thing you need is your objective, which I'm calling profit P. Okay, and again, I'm going to clear out this cell. I'll clear out everything just so we can type it in from scratch. Okay, profit, my objective is going to be in cell B5. Okay, right opposite my label. And I need to type it in according to my notes. Now, if you take a look at my notes, I'll bring them up briefly again. Here's my profit, my objective right here. Okay, so this is what I need to type. I need to type 60 times X1 plus 44 times X2. Okay, now X1 and X2 are in certain cells in the spreadsheet. Okay, so I'm going to go back to Office 365. Now remember, formulas start with an equal sign. Okay, because I'm asking Excel to compute something. Okay, and again, my profit is 60 times, so I need a multiply. Okay, and that's just the star, that's a shift on your 8 key, multiply. And then I want the cell that's going to contain X1. In Excel, all you need to do is click it and see it puts B2 right in your formula. Okay, and then to that, I want to add 44 times X2. So I'm going to click that cell. Take a look at the formula that's in the objective function cell. Equals 60 times cell B2, where X1 is going to be, plus 44 times B3, where X2 is going to be. Okay, everybody okay with the formula? Because again, I know not everybody said they were comfortable with Excel, so please ask. Everybody okay with the formula? Anybody questions about the formula? All right. Here's a piece of advice. When you're in a cell with a formula on Excel, don't enter. Tab off the cell. Use the tab key on your keyboard to tab off the cell. Okay? So I'm right here right now. You can also see it up here. If you're going to hit enter, do it up here. If you're in the cell, just tab off it. Okay? All right, now basically I can go back and I can still see the formula. See f of x up here? Okay, so here's the formula. Okay, but now it's evaluated to 0 because there's no values for x1 and x2. Okay. All right, the next thing I need to enter are my constraints. Now you enter in just the left-hand side of the constraint, and you enter it in as a formula. So let me go back to my notes again so you can see. Okay, first constraint is x1 plus x2. So I'm only going to be entering in the left-hand sides here. Okay. And I'm not going to need a non-negative constraint as a separate one. This is usually an option when you run the solver. Okay. But here are my constraints. All right. I have my production constraint and I have my labor constraint. So I'm entering in the left-hand sides of these. Okay. So again, I have a formula. So I'm starting it with equal. And my minimum production requirement is X1, which is up here. So click that cell, plus X2. Click that cell. Okay, and then just tab off the cell or hit enter up here in the formula bar. Okay. And again, I can see that. Okay, X1 plus X2. The way the solver in Office 365 works is it's going to require your right-hand side of your inequality to be in another cell. So I just usually type the right-hand side in another column. Okay, this is going to be a greater than or equal to. Again, I refer to my notes. Okay, so I know what's the right inequality symbol here. Okay, and then here's the right-hand side. Now I have my labor restriction. That's how many hours it takes to make the cogs and the sprockets. So that's equal. And it takes 5 hours to make a cog. So 5 times X1 plus takes 3 hours to make a sprocket, 3 times X2. Okay, that's, you can see, is my requirement for labor. Okay, and the maximum value I have there is 8,000. So this is not a formula. These are just constants. Okay, so everybody see how to set up the spreadsheet. Everybody see how to set up the spreadsheet? Okay. All right. These third-party solver things, now we can actually use the solver that we've put here. Okay. The first part says objective, pick the cell to optimize. Okay, so it says set objective. Click and choose the objective. Okay, so I'm going to click this cell because that's where the objective function is. See it? And then click. Okay, so again, you got to play with this to see what order they want it in. All right, so I'm going to, you see what happened? I clicked D5. That's the wrong one. All right, so highlight it. I'm trying to deliberately show you how to fix things. Right? It wants you to put your cursor in this box, then choose the objective cell. Okay, so again, I'm going to get off of here, click, and choose. Okay, right. Follow the directions. Okay, so now what's important is you see $B $5. Just for those of you who aren't comfortable with Excel, the $B $5 anchors this cell. So again, it won't autofill with anything. All right, we want to maximize this because it's profit, so click maximize. Okay, now it says variables, pick the input cells to change. Okay, so again, I'm going to assume I click in the box, and then I probably need to add them one on one. Add edit variables. So let's see if I can click that one. Let's see if it'll let me add another one. And then click OK. All right, and you can see I didn't get both of them. Okay, so I'm going to clear this out, and you just kind of delete it. Okay, so I'm going to go in here and watch how I'm going to do this. I'm going to click on the first cell, then drag to get a range. Click and drag and see if it will add those. Okay. All right, we've got B2, add, click and choose. B2. Wrong one. Okay. I want B3, so I'm going to type over this. Okay, let's see if it has the right ones. Okay, B2, B3. All right. Basically, what I'm showing you is using the solver as a third-party add-in is messy. Okay, the solver isn't a Microsoft product in Office 365. Okay, the solver here is a third-party product. You need to be careful what you're doing here. Okay, it's clunky. All I would say to you is add your variables one at a time. Click here, then click the cell. Click here, click the cell. If it doesn't look like what you want, go in and change them. And then at the end, you want to show them, okay? When you click OK, just make sure you're getting the right values. Here I'm seeing B2, which is X1, B3, which is X2. And you can see they're assumed non-negative. If this isn't selected, select it, okay? Again, this is much smoother when you use the desktop version because all of that is integrated into Excel and it's a Microsoft product, okay? So again, you can see my constraints are going off the screen. So let me click on constraints and that should close variables, okay? So add the formula cells with limits. So I'm going to click in here, okay, and see if I can add these. Okay, click the cell, okay, that has the constraint. Okay, this relationship isn't less than or equal to because I had to make at least 1,000. So I'm going to select greater than or equal to. And here I'm going to click the right-hand side. Okay, so I have the left-hand side of my constraint in cell B7. Here's the inequality, and here is the right-hand side. Okay, I'm going to add that, add another one. Okay, it says click the left-hand side. That's the labor. That one is less than or equal to, because I have a maximum of 8,000 hours. So I'm going to leave this inequality alone. And then I'm going to click the right-hand side. And then I should click OK, and I should see 2 of them. Now take a look. All right, it doubles my stuff. Okay, you don't want double stuff. Okay, you just want to make sure you've got the right ones. Okay, so these 2 are extras. I don't know why they're there. So I'm going to delete them. Okay, so like I said, this is not a Microsoft product. It's a little messy. Check your input at every step. Okay, check your input at every step. Okay, so now we should, I'm trying to see if I can get this over here. Okay. I've got my objective, I've got this. Okay, now model type. Okay, I just clicked and clicked again to make all of these sub menus close so I can see what else is down here. Okay, so model type. Okay, I don't think I need to do anything here, so don't worry about model type. Engines you want to select. Okay, you want a linear engine. This says non-linear. Okay, so standard linear programming simplex. That's what we're choosing. Okay, so I entered in my decision variables, my objective, my constraints, and you don't need a model, but you do need engine. Okay, so I basically picked that. And then here's the way you run it. Okay, see this little arrow up here? It says upload workbook and run the optimization. Because again, all of this is happening in the cloud. Okay, and you can see it's come back with results. It says, don't manufacture any cogs and manufacture 2,667 sprockets. Here's your maximum profit, $117,333.30. Okay, you exceeded your minimum production requirement and you used all your labor hours. Okay, so these variables that come back in column B actually give you the values you want. Here's your X1, here's your X2, here's your maximum profit. And you can see because you overshot the 1,000 that you had to make, you made a lot more than you needed to, right? That was the minimum. And you can see you used all 8,000 hours. Okay, so let me ask you another question. Please give me feedback. Understand how to run it and interpret the results. Okay, everybody all right with this? Everybody good with it? Please give me some feedback, folks. Do you need me to go over anything? Is there anything you're not understanding?
Oh, I didn't see anything when I click run.
Okay. Do you have a...
My result is to 0.
You got the same result?
No, 0. All of them.
You got both of them to be 0.
Yes.
Okay. So here's what I would suggest. Okay. And this is why it's important to try the 1.9 homework. Okay. Is if you get different values, okay, what you need to do is show me your spreadsheet, okay, as well as what you typed in over here. Okay, because again, I can't debug this unless your spreadsheet. Okay, fair enough. So if you're willing to do that, like show me your stuff, I'll be happy to debug this for you. Okay, this is much, much easier to run in desktop Excel. Okay, this is clunky, but you can get around this by just double checking what's in each one of these windows before you actually run the model. In other words, don't assume because you think you typed it in right that it's right. Because like I showed you before, sometimes it duplicates things. Sometimes you wind up with the wrong cell. So you have to double check. Shall we do this in desktop Excel so you can see the difference? What do you think? Want to see it in desktop Excel? Okay.
Yes.
Because I know some of you have desktop Excel. So I need to share this with you Okay, so give me a moment. I'll share the spreadsheet with you. Okay, so now I am in regular Office on my desktop. I'm running Office 2010. Okay, so you can approach this pretty much the same way. The only thing that's different is the way you load the solver. Okay, in a desktop version of Excel, you click on File and you click on Options. And this is all in the notes. Okay, so please don't say, I can't write it down that fast. You've got it in the notes. Options, add-ins, manage Excel add-ins down here at the bottom. Go. See, I've selected Analysis Tool Pack and Solver. You have to put a check mark in each one of the boxes you want. And then click OK. All right. The way you see that it's loaded is you click on your Data tab, and you'll see Data Analysis and Solver over here. Okay, it's on your Data tab. Okay, so much easier to load, okay, in desktop Excel, but not impossible in Office 365. Okay, so I'm going to basically do the same thing. I'm going to say number of cogs, X1, okay, and that's going to be here. Number of sprockets, okay, I'm going to make my column a little bit wider. Okay, so X, I'm going to have A1 and A2. B1 and B2 are going to hold the values. A1 and A2 have the labels. And then I can say profit, P, and I do exactly the same thing. I copy the profit function from the one I've developed. Okay, so it's important that you actually go through a certain amount of manual figuring out on paper for these problems before you try to hit the spreadsheet. And that's what you're going to upload for your exam. You're going to show me, here are my decision variables, here's my objective, here are my constraints. And I will give you most of the points if you can get that far. Okay? All right, so here is, again, my profit, which was 60 times X1, which is in this cell, plus 44 times X2. And again, notice how Excel shows you what cells are involved in your formula. Okay, and I'm going to tab off here. Okay, profit is 0 because my X1 and my X2 cells are zeros. And then I have my constraints down here. So I have my production constraint. Okay, and that was X1 plus X2 is greater than or equal 1,000. So I'm going to say equals X1 plus X2. I'm going to tab off that, and I'll put the 1,000 over here just for reference. Okay, so I'll make it look like the Office 365 spreadsheet. Turns out with a regular Microsoft Excel, you don't need it in a separate cell. It's going to make you type it in a dialog, but that's okay. I have it there, so I don't need to look it up. And then I have my labor constraint. Okay, and that was the number of hours it takes to make a cog, which is 5 times the number of cogs I'm making, plus 3 times the number of sprockets I'm making. And that's going to be less than or equal to 8,000. Okay, so this spreadsheet looks really similar to Office 365 Excel. Okay, so everybody is good with that? It looks the same, right? Now the difference is, since I have Solver up here on my ribbon, I don't get a panel on the right. I'm going to get a dialog box. So I'm going to click Solver, and it brings up a dialog box. Okay, and it has the same kinds of questions in there, like set objective. Well, my objective is pointing to the wrong cell, so I'm going to clear that out. Okay, and then all I need to do is click on the cell that has my objective function in it. Okay, so this isn't as clunky as that third-party add-in in Office 365, but I'm still double checking. Yeah, B4 has my objective function. I want to maximize it, which is the default. If you want to minimize something, you're going to have to select this button. Okay, now by changing the variable cells, this is the same as variables to be changed in the other dialog. Okay, now because this is ordinary Excel, I don't need to click on them one at a time. I can click and drag, and it gives me a range. Okay, so this is $B, $1, colon, $B, $2. And you can see it's showing you the range of your decision variables. Now I'm going to put in my constraints. Okay, and I'm going to add them one at a time. Okay, so add. Okay, cell reference. The left-hand side is the production constraint, and that isn't less than or equal, so I have to select the right inequality, greater than or equal. And you see what I mean here? This isn't looking for a cell reference. This is looking for a value. So I'm just going to type in my 1,000. Okay, so this is the only difference I can think of is in desktop Excel, the constraints right-hand side actually typed in as numbers, whereas in the Office 365 solver, you need to have a cell reference with the value. Otherwise, they work the same. Okay, I'm going to have another one to add, so I'm going to click Add. All right, and I'm going to click my labor constraint. That is less than or equal to 8,000, and I'm going to type in the 8,000 here. And then just like the other solver dialog box, I'm going to click OK when I'm finished. Now here's where you have to review what you typed in carefully. Okay, review what you typed in. I have the right objective, that's cell B4. The profit, I want to maximize it. I have the right variable cells. It's a range of cells, B1 and B2. My constraints are a production constraint in B6 that's greater than or equal to 1,000, and a labor constraint in B7 that's less than or equal to 8,000. Okay, also see, make unconstrained variables non-negative. And again, I get to select my solving method. This is the same as the select your engine, okay? That's going to be simplex LP, okay? LP is for linear programming because, again, all of our relationships are linear relationships, okay? And then just click Solve. Okay, and you can see I got the same values as Office 365. Okay, and they mean the same thing. Your X1 value is 0. Your X2 value is 2666. You could round this one up. Okay, here's your profit, maximum profit, 117,333.33. Okay, your production constraint, you made this many sprockets and cogs, and you used all your labor hours. Okay, and you have an option here of keeping the solver solution or restoring the spreadsheet back to what it was to start with. Okay, one thing I want to point out, but I'm not going to go into, is Excel also provides these reports. One that's particularly useful is a sensitivity report, which will tell you, hey, you know what? If you have a little bit more of this constraint, like more labor, your profit will go up by this much. So you don't need to rerun the whole thing. Although it's no big deal to rerun the whole thing. It's pretty easy. Okay, so I'm going to keep my solver solution here. Any questions? Okay, do you think you could set one up? All right, here's a question for you. Okay, so no, they will not be profit. They're not going to always be profit questions. That's what I want to do with we have maybe about 12 minutes left. What I want to do with the time we have left, now that we've slogged through Office 365 Excel and desktop Excel, you can use whichever one you prefer. Okay, and I know some of you don't have the desktop version, so you're stuck with Office 365. That's fine. Ask me if you're struggling with it, and ask me before you need to use it on the exam. Okay, and again, please don't stress about the exam. I'm going to be very generous with that question. Okay, and more concerned that you can set these up correctly in standard form. What do I mean by that? Maximize or minimize this objective subject to these inequalities. If you can get that far, then it's only a matter of playing around to get it to work in Excel. Okay, but to get to that standard form of an optimization is going to require you to read carefully and set up the problem carefully. Okay, so again, use whichever version of the spreadsheets you want. Okay, but what I want to take the rest of the class period is to show you how to set them up. In standard form. Okay, so again, what I'm going to upload as notes for this section is I'll show you again the problems in standard form, and then I'll attach my spreadsheet. Okay, so you can see how I set them up in Excel. Okay, so you can look at the objective function, you can look at the constraints and that sort of thing. But I'm not going to have time to walk through the Excel piece right now. I want to take time showing you how to set these up. Okay, so let's spend the rest of the time doing that. Okay, let's go over here to some sample problems. Okay, so is that okay with everyone to do that? Okay with everyone? I want to show you how to set them up in standard form. Okay, and then the assumption is you can run the standard form problem in Excel by setting up decision variables, entering in your objective function, entering in your constraints, and then using the solver. Okay, so this is the hard part. Okay, a contractor builds two types of homes, the Carolina and the Savannah. The Carolina requires one lot, $160,000 in capital, and 160 worker days of labor. Okay, so I'm kind of getting an idea of what my constraints might be here. Okay, I've got only so many lots. I've only got so much money to spend and only so many worker hours of labor. The Savannah requires one lot, $240,000 in capital, and 160 worker days of labor. Okay. The contractor owns 300 lots, has 48 million available in capital, and 43,200 worker days of labor. The profit on the Carolina is 40,000, and the profit on the Savannah is 50. Determine how many of each home type the contractor should build to maximize profit and find the maximum profit. Okay, so I know it seems like, I know Zainab, you just asked me, so is everything going to be profit? And the answer is no. Okay, I apologize. The second example is also using profit. Okay, sometimes there might be another quantity that you want to maximize that's not profit. Okay, and sometimes you want to minimize like a production cost. Okay, so just so you're aware of it, those are the most common things. You might want to maximize revenue instead. Okay, so you've got to read the problem carefully. And here's what I'm seeing. I want to maximize profit. And they're asking me how many of each home type should I build. Okay, so I'm starting at the end. And I know I have two of these, two home types. And this is my objective. Okay, so I'm starting at the end to get my decision variables and my home types. And again, you can call the decision variables x1, x2, xy, whatever makes sense. I call x1 be the number of Carolina homes? Okay, and let X2 be the number of Savannahs. Okay, so again, write it down. Okay, that way when you go over to the spreadsheet, you'll have everything in front of you. My objective function is profit, and I want to maximize it. Okay, and they tell me what the profit is. If you take a look on the Carolina, my profit is 40,000, and on the Savannah, it's 50,000. Okay, so I'm looking for profit. Okay, if I make X1 Carolinas, I have 40,000 times X1 is my total profit from Carolinas. 50,000 times X2 is my total profit from Savannahs. That's my profit function. Okay. Constraints are the things that limit my ability to make profit. And those are things like number of lots available, capital available, and labor available. Again, which I got from reading the problem. Okay, and then all we have to do is go back through the problem and look at each one of these. The Carolina requires 1 lot. The Savannah requires 1 lot. And how many lots does the contractor have? 300. Okay, that means the contractor can build at most 300 homes. Another way to say that is X1 Carolinas plus X2 Savannahs has to be less than or equal to 300. He may wind up maximizing his profit if he builds fewer than 300. Okay, so he's allowed to be less than. He's constrained by the amount of capital he has. Okay, so let's look at capital. The Savannah, the Carolina requires 160,000, and the Savannah requires 240,000, and he's got 48 million on hand. Okay, so there's my capital. So again, how am I going to do this? Well, you can basically say like this, 240. Okay, so 160 for each Carolina times X1 Carolinas, total amount of capital for Carolinas. Likewise, this is total capital for Savannahs. That has to be less than what he's got on hand, which is the 48 million. Okay, the last constraint, wish I had another highlighting color. Okay, basically is the worker hours. Okay, so the Carolina requires 160 worker days, and so does the Savannah. And he's got at most 43,200 worker days of labor. So that's your last constraint. This is the total number of worker days it takes to build all of the Carolinas, right? 160 per house, and you're making X1 of them. Okay, and 160 worker hours per Savannah, and you're making X2 of those. That has to be less than or equal to what you have on hand, which is 43,200 worker days. Okay, so now you have enough information to run this in Excel. You have enough information to run this in Excel. You've got 2 decision variables. Here's your objective function. And here you have 3 constraints in this case. Okay? Everybody all right with that? Okay, let me ask you a question at this point. Would you rather see me run this in Excel, or would you rather see how to set up another example? Okay, so please vote. Would you rather see me run this in Excel, or would you rather see how to set up a different one? Okay, come on, everybody vote. Okay, I've only got 2 people voting. Okay, more of you, come on, vote. Set up or see me run it? Okay, all right, for those of you who want to see this in Excel, here's my advice to you. If you can, stick around at the end of the class period and I will run it in Excel for you. Okay, but the vast majority of people want to see another example. So I'm going to go to another example. Okay. So here's another example. We have a cell phone company called Makita. They have 2 types of cell phones and at 2 different factories. Okay. So they assemble regular cell phones and camera cell phones at 2 different factories within the same city. During each hour at the first factory, 15 regular cell phones and 30 camera phones can be assembled at a cost of $100 an hour. During each hour at the second factory, 10 regular phones and 60 camera phones can be assembled at a cost of $150 an hour. They expect weekly orders for at least 15,000 regular phones and at least 45,000 camera phones. Okay, here's the question. How many hours per week should the company schedule at each location in order to be able to fill the orders at minimum cost? Okay, so here's my question to you. Look at that next to last sentence. Okay, what's the decision variables? What are the decision variables? What are the decision variables? Are they number of basic phones and number of camera phones? Is that what they're asking for? Look at what I highlighted. Right here. Feel free to unmute yourself if you want to just talk. You don't have to type it all. What do you think the decision variables are? First of all, how many are there? And then what are they?
Okay, well, it says how many hours per week
Should the company
should
schedule
they schedule?
at each location? How many locations are there?
At
2
two
different
location.
factories.
Yeah, good for
Yes.
you. Okay, so I have 2 variables, right? Okay, so let x1 be the number of hours per week at factory 1. Let's call them factory 1 and 2, okay? Because they didn't give us names. Factory 1. Okay, let x2 be the number of hours per week at factory 2. Okay, so contrary to what you might have thought when you started off reading this, the decision variables aren't the number of each kind of phones that you're going to make. Okay, they're the number of production hours you want to schedule. Okay, what is your objective? What are you trying to do here? Okay, so what's the objective? That's also highlighted. Feel free to speak up.
The objective is to find a minimum cost, like the
Minimum.
cost minimized.
Good. Okay. Objective is to minimize cost. Okay. Now here's the trick. Okay. Your variables x1 and x2 don't represent phones. They represent hours. Okay. So you need to find a way to build an objective function that's based off the number of hours in each factory. Can you see a way to connect cost to the number of hours at each factory? I'm highlighting. See that? During each hour at the first factory, hint, that's your X1 variable. You can make this much in the way of phones. I don't care about that. I care about cost. Okay, so what's the cost of an hour at factory 1?
$100.
$100. And how about factory 2?
$150.
Okay, so here's your cost function. $100 per hour times X1 hours, right? Look at what happens. Hours cancel out and you're left with dollars, which is a great number for costs, right? A great unit. You want your units to be dollars for costs. So it's important to understand what the units are of all of your numbers in the problem. X1 is measured in hours per week, right? Okay, so technically your cost will be in dollars per week. Don't worry about it. I'm just showing you here why it's important to pay attention to the units in the problem. Okay, and $150 per hour times X2 hours, and these cancel out. Okay, so here's your objective. 100 X1 plus 150 X2. Okay, that's cost in terms of hours that you're running each plant, each factory. Okay, what are the constraints? What constraints are there?
They expect to orders at least 15,000 cell phones.
Yeah, basically, you have orders. Okay, and let's basically talk about that in terms of regular phones and camera phones. Okay, so our order constraints, regular, camera. And again, what's tricky here is to realize I don't have a variable that represents the number of those phones, but they tell me, okay, that I need weekly orders for at least 15,000 regular phones. That's greater than or equal to 15,000. And at least 45,000 camera phones. So notice I'm putting in the right-hand sides first here. And now I need an expression in terms of hours at each factory. Okay, take a look. Okay. During each hour at the first factory, 15 regular cell phones and 30 camera cell phones can be assembled. Okay, so that's phones per hour. If I multiply phones per hour times hours, don't I get phones? Right? This is phones per hour, 15 per hour. Okay, and the other one is also 30 per hour. So if I multiply this by the number of hours I'm running each factory, right, I'm going to get total number of phones. Okay, so during for the first factory, this will tell me the number of regular phones I make, and this will tell me the number of camera phones I make, right? 15 per hour for each hour at factory 1, 30 per hour for each hour at factory 1. Okay? Likewise, there's the same type of information for factory 2. 10 regular cell phones and 60 camera phones for each hour at factory 2. So this is going to be 10 times x2, and this is going to be 60 times x2. Okay? And there's what you have. You're able to enter this into Excel. This is ready to be run in Excel. Okay, because I have my objective function, I have my decision variables, and my 2 constraints. Okay. What was difficult about this problem was you couldn't just jump to the conclusion that this was all about 2 types of phones. It is. But what they want to know is hours at each factory. So the answer to this problem will tell you, how many hours should I run production at factory 1? How many hours should I run production at factory 2? Okay. Did you see the way I needed to put the constraints 1 in each inequality here? Because this is x1 is factory 1, x2 is factory 2. Questions? Yes. Anybody questions? I think what you can take away from watching this is most of the hard work in doing these problems is not calculating. It's not even setting things up in Excel. It's this part right here where you carefully read the problem and make sure you understand what's being asked. Okay? And do it in this order: decision variables, objective function, constraints. Okay? So when I upload my work for our class, I'll not only show you this note page, but I'll also have an Excel spreadsheet that goes with it, so you can see how I did them and what answers I got. Okay, so for now, I'm going to stop sharing. Let me come back here and ask if you've got any questions on anything. Any questions on anything?